Hi everyone, good morning. My name is Teacher Rogers once again, and I wanted us to discuss something small in titration, or what we call part of the volumetric analysis, that is titration. We are talking about end of a reaction. The end of a reaction is the point at which the indicator changes color. The indicator changes color, so that means the reaction has ended. Or when we talk about rate of reaction, it is a point, especially with graph, it is a point at which the indicator changes. Not the indicator, it is the point at which the graph levels off. Okay, that is also the end of the reaction. Point at which the graph levels off. That also shows the end of the reaction. Now, I wanted us to show something small about this, how to titrate and get an endpoint. There are so many mistakes that learners make when they titrate. One, how they use these apparatuses. I have this, the retort stand with the clamp. I have the burette with me. There are two conical flasks here. Then we have two solutions, BA1 and BA2. And then I have with me the pipette. And I also have the filter funnel. Finally, I have the indicator. This is called methyl orange. You can see the color. It is orange. Now, how do I titrate and get a very good result? Now, normally when we talk about titration, there are two things you should do. Number one, the first titration is determined as the rough titration. Rough, why? It is used to determine the range at which, or the level at which the end point will be. So it is not a mistake when you over add the solution in the first titration. Why? Because you are determining the range at which the reaction is ending. But it becomes a crime or a sin when you now mess up again in the second titration. Why? You already know the end point, where it will be. Therefore, what you will do, you will move with your titration to some level. And when you're nearing the level where you stopped in the first titration, you become more careful. You begin to go drop by drop so that you determine the exact or the most accurate value. At the point the indicator will change color. Now see it. I have my burette here with me. Now I want to put it on the bottom stand. I have to make sure it is the burette can clearly fix below it there. Alright. I can tighten this one. Okay. So I ensure that it is erect, not slanting. That is one. Then two, the calibration or the reading on the burette should be facing me, the person going to do the practical. That is two. So I have fixed it there. This one is here and this one is here. Now I pipette. The instruction is telling me to pipette BA2, but BA1, but BA2 will be in the burette up there. So here is my BA2. I'm going to pour. But as I'm pouring, I ensure that because there might be spillage, they should not contaminate my properties here or my apparatuses, so that they are safe. I place them at a distance, then I pour. Okay. So up to there, my target is to reach the zero mark. So I pour fairly beyond. And then after pouring using the filter funnel, immediately I remove it. Why? Because if I leave it there and I begin to carry out the titration, remember there are some solution that will be left here. So this solution, as I'm carrying out the titration, assuming I leave it there, some may drop and it will not be accounted for. So I pick it away. Then using my eye contact, I adjust it. Because this is BA2, I adjust it to zero mark. Okay. My eye contact is very important. There you are. Zero. Now this is a color solution. What do I use? I use the lower meniscus, not the upper. It is only for colored substances that you use the upper meniscus, but for colored substances you use the lower meniscus. So the lower meniscus is on zero. Then I remove it, I put it there. come to this beer one. Now I'm pipetting. There is the ring here that the solution has to stop. Also on the lower main skirt, not upper. So I'm adjusting to that point. The moment it reaches there, the lower main skirt sitting on it. Aha, I stop. Then I transfer it into the conical flask. Now, for safety in comparison of the color, I can have two. Okay, I can have two conical flasks filled, or when I pipette in two different conical flasks. One is here, then I also pipette and I put in the other one, so that they are two for comparison of the color. Here we are. Alright, so all these two. Then the instruction is, after pipetting, I should add 2 to 3 drops of methyl orange indicator. 2 to 3 drops. So, using the dropper, you see, 1, 2. I think this is enough. You can see the color now. Here also, 1, 2. Right? This is the color. Now, to help me, to aid me see the color very well, I use a white background beneath the conical flask so that I can see very well. And I place it there, I place the other one there, and I begin the titration. My eyes will not see up, okay? My eyes will be seeing down because that is where the color change will take place. Alright? I can see. It is almost coming. There you are. Okay? The color has changed. So when I compare it with the first one, the original one, these are two different colors. This one is appearing orange. This one is almost like pink. You know, this is orange, some yellow also appearing, and this is now pink. You know? So this is my first. Then I come and I read this. This is reading 19.12, 19.2, and I record it immediately in my table. You know? So I started from 0.00, I ended at 19.20, because this is a burette 2 decimal place. My pipette that I used was 20.0 cubic centimeters, so I record there. Now, this one told me that the range, okay, at which this L point is between 0 to 19, okay? Now, I ask myself, is the solution from 19 up to 50 here enough? Yes. If it is enough, I continue from 19.2 there. But at this point now, I become more careful. How? I know the end point is between 0 to 19. I run the solution to around 15. Then I begin to put a drop and I shake. Because this one, I did not know the range. Therefore, I consider it as if I messed up. It was a rough equation. Now, 19 plus 19, when you add, that is almost 38. So I can run the solution up to around 35. Alright? Then I begin to add a drop and shake, add a drop and shake, add a drop and shake. Now watch this. Up to around 35, I can run this one very fast, no problem. Up to around 28, 29, there you are, 30. I begin now to be more careful, okay. 31, 32, still there, 33. I want to save time by this. So I have reached 35. Now I become more careful here. Here now I will take time. I will take time because I want to determine the best. Alright? I want to now determine the best. I add a drop. Okay? I add a drop O2, then I shake, and drop O2 and I shake, and drop O2 and I shake. See that? Oh, okay, it's almost there. One more drop. One. Are we there? Now you can see. So this one is appearing more orange than this because I messed up here. Therefore, this becomes the end of my reaction. Then I come and record. This is 38 exactly. That means I messed up in the first titration. That I called it rough. Why? Rough because I was determining the range at which the end point could be. So from 0, my end point was around 19.2. But this time I become more careful. So when you use this, okay, when you use this, number one, the rough time titration will not take long. Then it will also help you to save time in the second, the third titration because you know the range at which the endpoint would be. So you first run the solution very fast at a difference of the rough one, like 5 centimeters, cubic centimeters. Then I keep now adding drop by drop by drop till when I will add the last drop the way you saw me adding. Then I find the color has finally changed. Alright? So that is all I wanted to share with you today. Thank you very much and God bless you. If you have not subscribed, please subscribe so that you get more of these lessons. Thank you.